There, and today in this video lecture we are trying to know what is the principle of transmissibility of the force. In the last video lectures we have seen what is the force and how it is going to be imparting the motion to the system or to the body. And here without changing the equilibrium of that position or equilibrium of your body, then how we can transmit this force from one point to the other point in the line of action. So that's the process we are going to be called here is the transmissibility of a force. So here the definition will go. It states that the condition of equilibrium or of motion of a rigid body will remain unchanged if the point of application of a force acting on a rigid body is transmitted to act at any other point along its line of action. So in this process of transmissibility of the force, if a body is going to be subjected to any kind of the force, so then what will happen? It's going to be retain one of the equilibrium position. So in this case, without changing that equilibrium position, so we need to transmit the force from one point to other point through the line of action. So for this one, I had given the one example I am going to be presenting with the pictorially. So here I have taken one rigid body and A and B are the two ends of that rigid body I am going to be say. So then what will happen here? I was applied the force at F which is going to be moving towards the right side. So then in this case what will happen? That body is going to be tries to move along the direction of the force. So then in that part I am going to be recognizing the line of action of that body that I am going to say A and B. So then this is the motion of a body is going to be, it will come to know that it is moving towards the line of action of that body. But as per our definition, the state that the condition of equilibrium or motion of a rigid body will remains unchanged even though that forced from B to A, even though we are going to be shifting. So that point we are going to be concluding here. And here the same AB is going to be the force, that is the body we have taken, and next to act other point along its line of action. So then what happened? The force B at B that I am shifting to another point along the line of action. So that I am going to be taking here the force at A. So that means the B force is going to be shifted to the point A in the line of action. So in this case the motion of your body we didn't change. So motion of the body at the initial condition it's trying to move from inclined the x and y axis. Similarly, when the force is going to be shifted from B to A, this case also the body is going to be moving in the same direction. So in this is the way the force of transmissibility of the force we are going to be learning. So the content I mentioned here. So in the next continuation, so I have taken a prismatic bar. I am trying to apply that same force on a prismatic bar in this case. AB is going to be the prismatic bar and I was applied the force P1 at end A and which is going to be acting towards the left side. So it means that if you apply the force in this direction, the body is going to be trying to move in towards the left side of the member. At the same time, I want to keep that body in the rest condition. So then what will happen? I am applying the another force P2 which is equal in magnitude but in opposite direction I was applied. At the same time, these forces are going to be when the body is going to be in equilibrium condition. So it is clear that when these P1 and P2 in the magnitude point of view the same, at the same time their line of action also must be passed through the same. Then we can say that is the collinear forces is going to be. So in this case AB is going to be the line of action. So there we can see, so the force P1 and the P2 is passing to the line of action. So this is called the pull force. That means the body is going to be subject to the pull forces. So in the next case what will happen? So I am going to be trying. That is going to be at initial position the body is at the rest condition by the P1 and the P2 forces are going to be acting. The body is in the equilibrium position. Now I am applying the principle of transmissibility. The force P1 acting at A can be transmitted to act at B. And the force P2 acting at B can be transmitted to act at A. So then what will happen in this case? So the body is in the equilibrium condition, and the P1 and P2 I am shifting from B to A and A to B forces I am shifting there. So here that's going to be taking the prismatic bar, and then in this case the P2 force, initially it was acted at B and now I shifted at A. So then what will happen in this case, that force, initial condition it is a pull force, but now what will happen, this force is going to be acting towards the right side. And similarly, the P1 force is going to be, I am made to act at B. So then what will happen in this case? So rather than the body is going to be subjected to the tensile forces, this one is going to be subjected to the push forces. That means compressive forces are going to be developing inside the member. So that is going to be, in this case also, the line of action is going to be the same, because without changing the equilibrium position, you can transmit the forces from one point to other point in the line of action. So then in this case it is called the push forces. So then the new system of the forces acting on the bar as obtained by the principle of transmissibility does not change the condition of equilibrium of the body. So but from the point of view internal forces, the state of the tension, that means pull, has been changed to the state of the compression. That is, the tendency of elongating the bar has been changed so that the shortening of the bar. That's only the difference in this case. In the next case, what I am going to be doing, I am using the transmissibility of the force. So then the two forces P1 and P2 can be transmitted to the middle point C of the bar, such that there is no internal forces developed in the bar. So then that is the condition I had given here. So in the first two cases we have seen, and this is the another case where the P1 and P2 I brought to the middle point of the bar at C. So then in this case what will happen, already we told the P1 and P2, the magnitude is going to be the same and they are in the opposite direction, they exist on the collinear. At the same time, because of these equal forces, that point C, there is no internal forces are going to be developed inside the body. So then we can say there is no forces in this one. It is therefore clear that the principle of transmissibility can be used to discuss the condition of equilibrium or motion of a rigid body to determine the external forces acting on the rigid body. So it is going to be very clear that, so by using this principle of transmissibility, we are determining the external forces acting on the rigid body. But it should not be used to determining the internal forces and the deformation of the body. So from the discussion, what is the outcome, what we learned, and how we can think about this transmissibility of the forces. So then we are able to understand what is the transmissibility of the force. Without changing the equilibrium position of a body or the motion of a body, we can change the forces from one point to other point in the same line of action of the force. Then we can say that is going to be the transmissibility of the force. Then we have seen the application of the transmissibility of the force. The same we have taken the rigid body, and initially we are made it to subject to the tensile forces, and then we shifted to the compressive forces, and then finally there is no internal forces. That means we brought to the middle point of that one, P1 and P2 forces, then finally there is no internal forces are going to be developing. This way we applied this transmissibility of the forces from one point to the other point, and various parameters we have seen. Due to the force transmissibility on a rigid body, how the internal forces are affected, that's we have discussed. So thank you.